In this tutorial, I'm going to show you how to use the restart or checkpointing procedure in Xcompact3d. And for this, I'm going to do a small experiment with the Taylor Green case. So the starting point is going to be the input DNS Reynolds 1600. And I'm going to make a few changes into it. First one is I'm only going to run the simulation for 100 time step. So I last is going to be 100. And I'm going to produce a checkpointing file every 25 time step. Right. So first, I'm going to run the simulation for 100 time step, and it's going to be my reference simulation. And then what I'm going to do is I'm going to run two simulations from 1 to 50 time step, and then from 51 to 100, and I will show you that the results are going to be identical, showing that the restart or checkpointing procedure is absolutely not impacting the results. So the simulation is finished. I'm going to keep this file. My next step is I'm going to run the first 50 time step. So I just need to modify one parameter, I last. So this is going to be my first simulation. So first 50. Okay. And then what I'm going to do is I'm going to run the simulation now from 51. So I first is going to be 51. I last is going to be 100. And there is one last parameter to change, that is the I restart that needs to switch from 0 to 1, which means I'm going to read the checkpointing file or the restart file from the previous simulation. So if I look at my first simulation, now I only ran 50 time step. I've produced a different checkpointing file. All the information about the restart file of interest is in this info file here, so you can see all the information, and you can also see that there is a checkpoint file. Okay, so the in Xcompact3d we are only keeping the last relevant restarting file. This is, of course, if you are doing production job and the checkpointing or restarting file is a few gigabytes, you will not want to keep all the checkpointing files. So here we only kept the last one. And now I'm going to run again the simulation, but this time from 51 to 100. And then I'm going to compare the results with my first simulation. So the simulation is performed very well. So I'm just going to compare this second file with the 100 point out. And what we can see here is that I'm going at the very end for time step 100. You can see that the results are absolutely identical. There is no difference. The only difference in blue you can see is the wall clock time and the time per time step. So you can see that the restarting procedure does not introduce any bias in the simulation. So just to summarize, when you want to do a restart or when you want to use a restart, the only parameters to change are of course the first and last iteration, in this case 51 to 100, and don't forget to switch the I restart parameters from 0 to 1. 0 will start from the initial condition defined in the BC file, and I restart equal 1 will read the latest available checkpoint file. Another parameter that might be of interest for you is the I checkpoint, which is the frequency at which you are going to write the checkpoint file. This might be of importance when you are running a production job and there is a crash. So you might want to save and to write this checkpointing file more often than less often.